Sir, I am fine, sir.
Okay, good evening. So लास्ट वाला क्लास आप लोगों को समझ में आया?
Sir. Yes, sir.
Okay. So in that last class, or in the first class, we have discussed about simple harmonic motion, right? And I told that simple harmonic motion actually the simplest case of oscillation, because you are taking that number n, x to the power n, and you are taking small number. Okay. What? You are taking small n, and your equation become for simple harmonic motion, it become basically minus kx. Okay. And this is the simplest case. If you take n is large like 3, 5, and so on, then that equation of motion will become so complicated, and that will goes to nonlinear dynamics. Okay, but it has so much importance of simple harmonic motion because it can tell you many things about your real application, like the solid or atom inside solid, they are vibrating as like a simple harmonic motion. Okay, so many properties are governed by that lattice vibration or simple harmonic motion inside the solid. Not only that, your molecular physics, when you will go to that molecular physics, that molecules or atoms inside that molecules, they are vibrating, and that is they are giving you that molecular spectra or vibrational spectra. And from that vibrational spectra, you will get many things, many important properties. So that's why that simple harmonic motion is so much important. So everywhere you will get simple harmonic motion. When you will go to classical mechanics, you will get simple harmonic motion. When you will go to quantum mechanics, you will also get simple harmonic motion or simple harmonic oscillator. And we have also observed when, so suppose this is the case, this is the equilibrium position, x equals to 0, and let us assume this is the extreme position, and this amplitude is capital A. Okay, so when that particle is making displacement from x equals to 0 towards positive side, then your equation or displacement equation was xt equals to a sine of omega t. Okay. When it is making displacement from x equals to 0 towards positive x direction. If it is making displacement from x equals to 0 towards negative x, it will be minus a sine omega t. But right now, I'll deal with this displacement, that is at t equals to 0, it is at equilibrium position. Now, when you will apply force, it will displace towards positive x. So in this situation, xt is like this. We have also seen v of t or velocity as a function of time. In this situation, that will be a omega cos of omega t, and you can further write it omega into root over a square minus x square, right? And acceleration also is a function of time, and that was minus omega square x, or you can write omega square a sine of omega t equals to minus omega square x, right? X of t. Now my plan is to plot this displacement, velocity, and acceleration as a function of time. I'll plot it. So let us define first what is actually time period. Time period means on complete oscillation. Let us assume that your oscillator is at x equals to 0. It will go to extreme position, then it will come to mean position, it will go to negative extreme position, it will come to your mean position. So this is on complete oscillation. It will go to here, come back, go to this direction, and again it will come back to mean position. This is on complete oscillation, and time required for on complete oscillation is known as time period, and that is basically defined by t, right? Capital T. So t is time period. So if you substitute that t, you know that there is a relation between omega and time period, right? Omega is angular frequency. So in terms of time period, this equation can be written as a sine of omega will be how much? 2 pi by capital T, and you have small t. Okay, this equation, this term I can write like v as a function of t, that I can write a omega cos of, in place of omega again I'll write 2 pi by t, and you have time. Okay, and same thing for acceleration again, I'll write it. So what I can write here, minus omega square a sine of 2 pi by t into t. Okay, is this part clear to all? So just I have substituted omega in terms of time period, and I have assumed that at time t equals to 0, that was your system at x equals to 0, it is making displacement towards positive side, and it will complete on complete oscillation. For that, the time required, that is nothing but time period. So this x, v, and acceleration, it becomes a function of time. So now I'll plot that three curves. So is it clear to all? Is there any question now? Is it clear to all?
Yes, sir.
Okay.
Yes, sir.
So I can easily plot now. So these things, first I will plot your x of t. So again I will write this sine of 2 pi by capital T, then small t. So if you plot this function or displacement as a function of time, okay, x of t. So this is a sinusoidal function, right? So at time t equals to 0, your oscillator is at 0. So obviously displacement will be 0. Now the function will be like this, because this is all about your sinusoidal function. So at time t equals to 0, its displacement is 0. Now how much time it will take to go from here to here? That will be capital T by 4, because capital this time will be capital T by 4. Then it will come to mean position from extreme position, that will again be capital T by 4. It will go from x equals to 0 to this extreme position, it will take capital T by 4, and from this extreme position it will come to mean position, that will be capital T by 4. So what I'm trying to say you, that at extreme, from this position to extreme position, that time is nothing but capital T by 4. So यहाँ से यहाँ जाने के लिए कैपिटल T by 4 लगेगा, यहाँ से वापसी आने के लिए कैपिटल T by 4 लगेगा, फिर मीन पोजीशन से इधर जाने के लिए, इधर एक्सट्रीम पोजीशन जाने के लिए कैपिटल T by 4 लगेगा, फिर वापसी आने के लिए कैपिटल T by 4 लगेगा. तो 4 into capital T by 4, that is your time period. So at T by 4 you will have maximum displacement. So this displacement is maximum, and that is nothing but capital A, and that time corresponds to capital T by 4. Okay, now again, now your situation is at capital T by 4, your oscillator is here. So again, after capital T by 4, oscillator will be here. At this situation, displacement is 0. So total time is capital T by 4 plus capital T by 4. So at capital T by 2, your displacement is 0. Now you can think, when it will go to this extreme position, the displacement is minus A, right? So at this situation, time will become
T by 4.
exactly 3t by 4. So this displacement will be minus A, and this is nothing but capital T, right? Because now your oscillator will come to its initial position. Okay, is this part clear? Now I'll write for velocity, and you know that velocity was a omega cos of omega t. So if you plot this velocity as a function of time, or in terms of time period, these things you can explain from here itself, this displacement. So if you plot in place of small t, capital T by 4, it will become pi by 2, right? So at this situation, x will be how much? Capital A. If you plot capital T, sorry, in place of small t, if you plot capital T by 2, it will become sin pi, so it will be 0. So this point corresponds to this, and you can explain other terms also. So whatever I have plotted, you can explain from this equation itself. Okay. Now I'll plot v of t as a function of time. Now you see, when time is 0, your velocity will be a omega, and that is actually maximum, because cosine, the value of maximum value of cos is 1. So when time is 0, oscillator is at mean position, and you know at mean position you will have maximum velocity. So the behavior of v versus t curve will be, so this point corresponds to what time?
T/4 पर 0 होगा सर, T/2 में मैक्सिमम होगा next second.
Exactly. So this time point corresponds to t by 4, right?
Yes sir.
Then what does it mean? Your oscillator is at this position. Now it will come to negative x direction, right? So your velocity will be
T/2.
exactly. So इस position में क्या हो जाएगा? जब आपका t by 2 है, यहाँ पे आ जाएगा, ना? Did you get what I'm saying? So at initially your oscillator is at this position, so velocity is maximum. At t by 2, at extreme position, velocity will be 0. Again, so at t by 4 extreme position, velocity will be 0. At t by 2, again it will come to this position, velocity will be maximum, but since this is going to negative x direction, that's why that velocity is coming in negative. So if you take magnitude, it will be positive. So this minus peak actually representing the direction. So this point corresponds to a omega, and this point corresponds to minus a omega. And you can plot put that limit. So t by 4, this will be your t by 2, and this will be 3t by
3T/4 and
Okay.
T.
exact. So this will be again your t. Is this part clear? Is this part clear to all?
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now we'll see what about acceleration. So it was nothing but minus omega square a sine of omega t, and omega t is nothing but 2 pi by t, and you have t. Okay, so if you plot this curve, this side you have time, this side you have acceleration as a function of time. So time, when time t is 0, your oscillator will be here. Or you can say that acceleration will be 0, right? But at time t by 4, when small t equals to capital T by 4, you will get minus omega square a. So your curve will be like this. So this point corresponds to t by 4. This will be your t by capital T by 2, and this will be your this will be your t by 2. This will be 3t by 4. Okay, and this magnitude is actually minus omega square a. This will be your plus omega square. Okay, just you have to substitute that limit, small t. If you substitute t by 4, you will get minus omega square a. If you substitute small t equals to capital T by 2, you will get 0. Okay, and so on. So these are very simple things, right? Is this part clear to all?
Yes sir.
Okay.
Yes, sir.
Yes, sir.
Now what about kinetic energy? So kinetic energy was your, and that is basically, I denoted that capital T, that is basically half am v square, and you know v is velocity. If you substitute this, v equals to how much? A omega cos omega t. So it will be half m. In place of v, you have to substitute a omega cos omega t. So obviously you will get a square omega square cos square omega t. And you know omega, I'll write that omega again. Omega in terms of time period. So it will be 2 pi by capital T, then you will have small t. Okay. So if you plot this as a function of time period or as a function of time, so it will be so when t is 0, you will have maximum kinetic energy, and it is obvious because your oscillator is at mean position. So obviously you will have maximum kinetic energy at time t equals to 0. Okay, but when time small t becomes capital T by 4, this factor will become pi by 2 and cos square pi by 2 will be 0. So at capital T by 4, you will have 0 kinetic energy. And this curve will not be straight line. There is some curve, right? Curvy nature. Okay. And again, if you substitute, now you see this function is cos square. And so you will never get negative value, right? Always you will get positive value. And these things is obvious because you are dealing with classical mechanics, and kinetic energy will never be negative because cos square function is not never be negative. So how the curve will look like? Okay, so this point corresponds to what? Capital T by 4, right? And this is basically representing when the oscillator is at extreme position. Now these points corresponds to what? Basically capital T by 2, because at this time your oscillator now again returning to mean position. Now this point corresponds to 3T by 4, because now your oscillator where it is now negative extreme position. So kinetic energy plot will be looking like this. You will never get negative value because you have cos square function, right? And cos square function will always give you positive number. So kinetic energy will be looking like this. Is this part clear to all? Is this part clear to all?
Yes, sir.
Okay.
Yes, sir.
Now I'll ask a very simple question. Can you tell me what will the average speed of a simple harmonic oscillator in a complete oscillation or in a complete cycle? So what I'm saying, what will be the
Zero is
exactly? So average speed of your oscillator. So what is the question? Question was, what will be the average speed of your oscillator in a complete cycle? So average speed, let us assume V average. So what is the definition? Average velocity will be nothing but total displacement, right? Total displacement divided by time. तो आपने क्या किया? एक कंप्लीट साइकिल के लिए कितना टाइम लगता है? कैपिटल टी, राइट? क्या क्वेश्चन सबको समझ में आई ना? क्या क्वेश्चन पूछा था? Did you get what I asked question?
full cycle average velocity.
हाँ, एक फुल साइकिल के लिए एवरेज वेलोसिटी कितना होगा? तो फुल साइकिल के लिए आपका डिस्प्लेसमेंट कितना है? 0 है, और फुल साइकिल के लिए टाइम कितना लगता है? कैपिटल टी. सो बेसिकली इट विल बी 0. 0 by capital T, it will be 0. Okay. Okay. Now suppose another interesting problem. Suppose you have, shall I erase this part?
Yes, sir.
Yes, sir.
सबको समझ में आ रहा है क्लास में?
Yes, sir.
Yes, sir.
किसी का कोई डाउट?
No, sir.
Okay, good. Now what I'm saying, suppose a particle, this is a question, right? So suppose a particle is making simple harmonic motion and its maximum acceleration is given. Maximum acceleration is given as alpha. Okay. And maximum velocity is given as beta. Okay. So you have to prove, or you have to show that the time period of oscillation will be 2 pi beta by alpha. So suppose a particle is making simple harmonic motion, its maximum acceleration is capital alpha or alpha, and its velocity, maximum velocity is beta. So you have to prove the time period of oscillation will be 2 pi beta by alpha. So you know maximum acceleration. How can I write? Let us assume A is the amplitude. Okay. So maximum acceleration will be how much? Omega square A, right? Where omega will be angular frequency. Right? And you have maximum velocity, that will be how much? Anyone?
A omega.
Exactly. So it will be omega A. So alpha by beta will become how much? Simply, if you divide alpha by beta, omega square A divided by omega A. So it will simply become omega,
Omega.
and you can write omega is nothing but 2 pi by capital T, right? So from here you will get time period will be 2 pi beta by alpha. Okay. Is this part clear?
Yes, sir.
sir.
Yes, sir.
लिख लिया आप लोगों ने?
No, sir.
हाँ, जब लिख लोगे बता देना, ठीक है? You complete?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now the displacement of another question, the displacement of a particle is given as xt equals to a sine of omega t plus b cos of twice omega t, where a and b are constant, omega is angular frequency. So is this equation representing simple harmonic motion? Is this equation representing simple harmonic motion? The question I am asking, is this equation representing simple harmonic motion? That you have to check. So you know how we'll do this? Anyone? So for simple harmonic motion, if you remember, del square x by del t square, that should be equals to minus omega square x. Now can you please check, is this equation will show this kind of behavior? So this is the condition for simple harmonic motion, right? Now if you differentiate your given equation, so what you will get basically del square, let me derive or give do the first derivative. So if you differentiate this equation with respect to time, you will basically get a omega cos of omega t plus 2b omega, right? And you will have minus sign, of course, sine of twice omega t. Now if you further differentiate with respect to time, del square x by del t square, you will basically get minus a omega square. Okay, and you will have minus 4b omega. Sorry, I forgot to write that sine term here. So you'll get sine term also, sine of omega t minus 4b omega square cos of omega twice omega t. Is this correct, right? Is this okay? Now, if you take minus omega square common, because only minus omega square will be common from here, you will basically get a sine of omega t plus 4b cos of twice omega t. Right? So this is not x, right? This is not x because x is nothing but a sine omega t plus b cos twice omega t. So this you cannot write like minus omega square x. So that's why this equation will not represent simple harmonic motion. Not simple harmonic motion. Okay. Is this part clear? What I'm saying?
Yes, sir.
Okay. Shall I erase? आप लोगों ने लिख लिया?
Yes, sir.
Yes, sir.
Yes, sir.
Everyone? Okay.
Yes, sir.
Okay. Now we'll calculate the time average of your kinetic energy and potential energy.